So for our project, we are exploring velocity and other rates of change, specifically in regards to derivatives. So for simplicity's sake, we're going to start off with a position graph. Very simple, just x squared. It's going to look like that. And so to find the velocity equation and graph from that, first you're going to want to find the equation by taking this exponent, bringing it down as a coefficient. So take the 2, write it down, write the x, and decrease the exponent by 1. So 2 to 1, you don't have to write that, it's implied. And then you would graph that, which you know would just be a straight line with a constant slope. And then to get the acceleration equation and graph from that, you just take the derivative again, take the exponent, which is just 1, bring it down as a coefficient, so it just stays a 2. And this time when you decrease the exponent of the x, you would decrease it from 1 to 0, which means that just anything to the 0 power is 1. So it would just be 2 in this case, which would be a straight line with no slope, just like that. And so if we want to see a pattern here, you go from a changing slope to a constant slope to no slope. And that's how they're all related and how that's the pattern that they would follow.
Okay, so now for an example. First, let's note that we'll be starting with our position equation, which is p of t. Now, to find velocity from that, velocity, which is v of t, we're going to take the derivative of p of t. So we're going to write or p prime of t. And then finally, to get the acceleration from that, acceleration a of t, or v prime of t, or p double prime of t. So let's just note that. There we go. So let's say we start off with the equation p of t equal to 2t squared minus 4t plus 8. So our velocity graph, v of t, would be the derivative of this p of t, right? So we'll start over here. We'll take this exponent of 2 and multiply it times the coefficient 2. So we have 4 and t, and since we decrease that by 1, we don't have to write that. So 4t minus the derivative of 4t is just 4, and then the derivative of a constant is 0, so we don't have to write that, so that just goes away. So now we have our velocity equation of 4t minus 4. So now we're going to set this equal to 0. So 4t minus 4 equal to 0. From there we can do 4t equals 4 by adding this 4 to both sides. So 4t equals 4. Now we can divide both sides by 4 and end up with t equals 1. So now we're going to make our sign chart. So we're going to go over here, just for some more space, and make that sign chart. So we have 2 and then 1, 2, 3, 4. There we go. So we'll have t, and we'll have v of t. So we're going to have 1 in the middle here, and then we can put a 0, 2 on the other side. So if we set, well, we already know that this is going to be equal to 0 because that's what we just found over there. Now we're going to plug in a 0 for v of t, and if we do that, we'll get 0 minus 4, which is negative 4, so we know that this is negative. And then we'll do the same thing with 2. We'll plug in 2, and so that'll give us 8 minus 4, which is 4, which is a positive number. Positive. So we can tell that the position is going to be moving to the left from 0 to 1, but then moving to the right from 1 to 2 because of the sign chart.
All right, so now we're going to be talking about average rate of change. So when you're given a function and you want to find the average rate of change from one number to the next number, from in this case we have 0 and 10 and have them color coordinated, you want to take the function of the bigger number, this case is 10, so q of 10, minus the function of the smaller number, so q of 0 in this case, over the bigger number minus the smaller number. So, as you can see, since it's from 0 to 10, you do q of 10 minus q of 0 over 10 minus 0. Q of 10 is going to be 240, and q of 0 is 0, so it's just 240, and then 10 minus 0 is 10. 240 over 10 is 24, so the average rate of change for this would be 24, as you can see. And then another way to apply this is when you're given a table and you want to find the velocity. So if you're given like miles and hours and you want to find the velocity, say at time 10, well, you only have 0, 3, 7, and 11, but 10 is between 7 and 11, so you find the average rate of change from 7 to 11. So what that means, let me color coordinate, 7 is going to be blue, 11 is going to be pink. So again, you're going to do the bigger number minus the smaller number for the hours. So the function of 11 is going to be 20, as you can see in the chart. So it'll be 20 minus the function of 7 is 8, and then over the actual hours, which are 11 and 7, so 11 minus 7. And then you get 20 minus 8 is going to be 12. And 11 minus 7 is going to be 4. And then you get 3 miles per hour as your velocity at time 10. So when you want to look at time 10, you find where 10 would be in between 7 and 11. The function of 11 is 20, sorry. 20 minus the function of 7, which is 8. 20 minus 8 is going to be 12. And then 11 minus 7 is going to be 4, so 12 over 4 is 3. And then you have your units. Okay, and these are just some reminders that I thought I should put in at the end. So probably the most important one is chain rule. So look at the top problem. We have f of x equals the sine of cosine of x. So you want to take the derivative of the inside first, so cosine of x, which is negative sine of x, and then multiply that by the derivative of the outside, which is sine of cosine of x. So the derivative of sine is cosine, so cosine, and leave the inside the same, cosine of x. And so the derivative of f of x would be the negative sine of x times the cosine of x. And then for this next one, g of x, you have the cosine of x squared plus 2x. So you do the derivative of the inside, which is going to be 2x plus 2 times the derivative of the outside, which is cosine. And the derivative of that is negative sine, and keep the inside the same. And then you would get, when you simplify that out, it would be negative 2x minus 2 times the sine of x squared plus 2x. So the derivative of the inside is 2x plus 2, so 2x plus 2. The derivative of the outside is negative sine, so negative sine, and keep the inside the same. I took the negative and distributed it out here, and then put those in parentheses. And then the next thing to remember is when a question asks if a particle is speeding up, that is asking if the sign of acceleration and the sign of velocity are the same. Because if you have a positive velocity and you are accelerating positively, that means your velocity is getting more positive, which means you are getting faster. If you have a negative velocity and a negative acceleration, that means your velocity is getting more negative, which means you are going faster, because in both cases, the magnitude of your velocity is getting larger. So when the sign of acceleration and velocity agree, you are speeding up. When they disagree, you are slowing down. Also remember that the average rate of change you would use when you have tables or when you're doing f of b minus f of a over b minus a. And then instantaneous rate of change is when you find the derivative of a function. So that wraps it up.